So what you're going to do is you're going to do everything we've done so far, and now you're going to move on to StatCrunch. So again, our outline for hypothesis testing: make the statement, collect the data, and do computation, analyze the data to see if it's sufficient to make a conclusion, and state the conclusion. We're going to look at the same hypothesis test for the mean and proportion that we did in the earlier PowerPoints. The first mean was about 639 minutes for screen time. We wondered if it is actually more for community college students, and we're going to test this with alpha equals 0.05. So we have a claim with a right-tailed test. And here's how we're going to do StatCrunch. It's going to be very similar to what you were doing with confidence intervals. We always check the data, compute the sample statistics, check initial conditions, and then we use StatCrunch. So we're going to do a t-stat. Same thing as with a confidence interval for the mean. One sample with summary, and this looks exactly the way it did before. But this time we're going to click on hypothesis test for the mean. We put in our sample mean, sample standard deviation, and sample size. This matches our template, which I did on purpose. So once you've got it on your template, you'll just copy it in here because you've already found the data. And we've already written out the hypothesis test, so we just have to change this to match the 639. And you click. It repeats what the hypothesis test is, tells you your sample mean, and it gives you a t-stat, which is called the test statistic. And it gives you the p-value. So in this case, we have a p-value that's 0.03 and a test statistic of 1.95. Oops, clear that away. So now we analyze and we look at the p-value, which is less than 0.05. Therefore, we can reject the null hypothesis, that hypothesis that said there is no change, and accept the alternative hypothesis. So the conclusion is we have sufficient evidence to support the claim that the mean number of minutes of screen time is more than 639 minutes. We don't know what it is. It doesn't match our sample necessarily, but we do have enough evidence to say, because our data was so extreme, we believe the mean is actually higher. Going back to the test for the proportion, 24.5% of all US residents who live in renter-occupied housing units lived elsewhere for a year. We think it is less for our students, so we do a survey and ask, is this unusual enough data to provide sufficient evidence that the rate of moving for our students is less than 24.5%, and conduct a hypothesis test with alpha equals 0.01. So here's our statement. P is 0.245 and P is less than 0.245. That's our claim in our left-tailed test. So we go to StatCrunch, proportion stats this time. So again, it just matches what we did for confidence intervals, proportion stats, one sample with summary. We're asked again the number of successes and the number of observations. That's directly from the sheet where we can write it down. And then to fill in the hypothesis test information. If you're asked for the initial conditions, same thing as when you were doing the confidence interval, random sample, less than 5% of the population, and n times p hat times 1 minus p hat has to be greater than 10. Greater than or equal to 10. So here's our data. When we click compute, we get a test statistic, which is a z-stat. And we get a p-value of 0.09. That's not less than the 0.01 we had asked for. So because the p-value is 0.0935, which is greater than our alpha, we cannot reject the null hypothesis and cannot accept the alternative hypothesis because our data isn't far enough from the old data. So we don't have enough evidence to assert that the proportion of Bristol Community College students who have moved this year is less than 24.5%. We don't say that the alternative is wrong, we just don't have enough evidence. If we had taken a larger sample, it may be that we would have sufficient evidence. So that's how we do it. That's it for StatCrunch. So if you go into the classwork, I wonder if that's